Hi students, today we are going to discuss about IGCSE Forecast Examination 1 2022 and the subject is Chemistry Paper 6 Alternative to Practical. Okay, so completely let us discuss about this paper. So shall you get started? This is question number 1. Basically, the paper 6. The first questions will be asked related to the experimental techniques and labeling the diagrams. Okay, and you must be prepared for labeling the diagrams, or it's going to be a kind of a experimental technique questions. So of course here we could see the first number. The diagram shows the apparatus used to reduce copper to oxide with hydrogen. So here you can see this hydrogen actually gas passed and it is being reacted with copper oxide. Of course the steam gonna produce, and then here the diagram, it is like a colorless liquid is produced here, and it was surrounded by ice, then the excess hydrogen burning in air. So this is the experimental diagram setup is given. So let's see how we're gonna answer this type of questions and basically what they have asked. So the first one is A, complete the boxes to name the apparatus. So we are going to write the name of this apparatus here. So here you could see one box and other box is here. So what is the name of this equipment? So basically it is, right, we can say just stand, or you can say retort stand. Isn't it? It's very simple. And the next one is next box you can fill with the answers here. What is called? It's going to the beaker. This is beaker, right? So right here, it's going to be the beaker. So you have already filled it, so you're gonna get 2 marks for this questions. Very simple, right? Now let's move on to the B. Use an arrow to indicate where heat is applied. So you have to indicate the arrow, so where heat is applied, so it's clearly visible. Yeah, you could see the place we supposed to be heated, right? So can you see, just you denote the arrow marks over here. So here the arrow should be drawn, arrow marks, because here the heating process has drawn as a diagram here, copper oxide to be heated, right? So you write over here, this is first question number 1, B. Okay, so you just label it so that the teachers who is correcting a paper, he will get clarity about it. Okay, so let's do the next question. The color of the copper oxide changes from dash to dash. So basically in this diagram you could see they're talking about the copper oxide to be reduced with hydrogen. Okay, that means here the hydrogen gas react with copper oxide. Okay, and it's gonna form what? This copper will be reduced, right? So what will you get it? You are going to get it water, and the copper will be displaced. So basically this is displacement reaction, right? What is displacement reaction? The more reactive metals gonna displaces the less reactive metals. Here you talk about the hydrogen and copper. So copper is less reactive, and whereas hydrogen is more reactive. So hydrogen can displace copper, and then the water will be produced, the product, and the copper. So make sure that this copper oxide, this is actually black color. Okay, this is a black copper oxide. When it is being reduced, so it's formed copper neutral metal. So it's actually a red brown. Okay, so copper is a appearance, you could see it's like a red brown. So isn't it? So in this chemical equation, black copper oxide turns out into red brown. Okay, so here how you gonna answer? So you can write here the color of copper oxide changes from which color to which color. What is the answer you have to write here? What color changes? Here, black to reddish brown, right? So just now I have told you the copper oxide to be black, and where copper is actually red brown. So right here, okay, it's going to be the black, and then this going to be the copper will be red brown. Is it clear? Okay. So suggest a reason why YouTube is surrounded by ice. So why here this is the YouTube, right? Can you see the diagram here? This kind of, it is surrounded by ice. So basically it is because to condense the liquid form. So whenever this reaction is taking place, hydrogen react with copper oxide, so you will be getting the steam in the form, water will get in the form of gas. So that gas can be condensed here, so in the form of liquid. So basically to condense the liquid, so the gas will be collected in the form of water. So what is that process we call? That is, we call it condensation. So basically to condense the liquid, we use here YouTube. So just write the reason, the condense, to condense. Okay, so no queries. So let's answer the next questions. First bit, identify the colorless liquid form here. So it is clearly sent to you. What is the colorless liquid produced? In the chemical reaction, already I said the colorless liquid is going to be the water, right? When hydrogen react with copper oxide, and the copper oxide being reduced to form a colorless liquid H2O and then copper neutral metal. So the identify the colorless liquid is water, right? So simply write water over here. Okay, next answer is second bit. Give a chemical test for this liquid. So it is well known to you that in fact what we're gonna go for the test of water. So basically there are two important tests for water that we can identify the presence of water. So what is the main test? So you can use anhydrous copper sulfate, or you can just use cobalt chloride paper also, that's fine. Okay, so if you use cobalt chloride paper, you can use. So test is cobalt chloride paper or anhydrous copper sulfate also you can use. So here just let me name it cobalt chloride paper. What is the result? The result gonna be blue to pink. If there is water, then it will become blue will turns out into pink color. Okay, so chemical test for this water is cobalt chloride paper. The result will be blue to pink, or you can use anhydrous copper sulfate. If there is water, then it will change from white to blue color. So anything is fine, any one test you can do. Even by means of boiling point also you can do it, because water will boil at 100 degrees Celsius. By means of boiling point also you can test the liquid. Okay, especially water. How could you show this is pure? How could you show that this liquid is pure? So purity basically can be checked by means of boiling point or melting point, right? So here we are going to write answers. The purity of water is going to be checked by means of boiling point. Boiling point. Okay, what could be the boiling point? 100 degrees Celsius, right? Okay, so if the water boiling point or water boils at 100 degrees Celsius temperature, then you can say the water is actually pure. If the water boiling point is above, then there might be impurities. That's not going to be the pure water. So basically, the water purity can be checked by boiling point and melting point as well. Okay, now the question number 2, it's also very simple investigation questions. A student investigated the rate of reaction between hydrogen peroxide and aqueous potassium iodide. When the chemical react, they form iodine. Third, sodium thiosulfate solution react with iodine and then can be used to show how fast the reaction proceeds. A, you read carefully, and this is going to be a very easy question for you, as far as I feel. Okay, so bureau was filled with this mark 0.0 centimeter cube mark with the sodium thiosulfate. So these are the bullet points. So just underline the compound so it will be easy to understand. Okay, with the large measuring cylinder, 100 cm cube of distilled water were poured into a conical flask using a small measuring cylinder. 6 centimeter cube of sulfuric acid and 1 centimeter of starch solution and 4 centimeter cubed of aqueous potassium iodide were added to the flask. 0.5 centimeter of sodium thiosulfate solution was added from the burette to the mixer in the flask and then sugar to the mix. The reaction was then started by adding 3 cm3 the hydrogen peroxide solution to mixer and then timer started. Timer started. The time taken for the blue color to be appeared was noted. The further 0.05 cm3 of sodium thiosulfate solution was added to the mixture in the conical flask and then swilled and then blue color disappeared. The time when the blue color reappeared was noted. The experiment continued by adding further 0.5 cm3 portion of the sodium thiosulfate solution until a total of 3.0 centimeter cubed of solution of thiosulfates had been added. Noting the time at which the blue color reappeared. Use the timer diagram on the page for to record the time in seconds in table. So there are going to be the timer diagrams, perhaps. Yeah, this is the timer diagram, and total volume of sodium thiosulfate solution is added in terms of cm3 it is given. Okay, and you have to write the time at which blue color appeared in seconds. So unit already is mentioned in second, you have to write. Okay. Okay, very good. So let's answer this. So basically this type of question is easy, and look at it, how many marks this? It's going to be 3-mark questions. So very carefully do it, and while counting the seconds, so please consciously you have to do it, because once the first one is get wrong, if you make mistake, then that's gonna be a mistake for all of them, because based on this we have to plot the graph. Okay, locate your timer diagram. The outer circle is meant for second and the inner side circle is actually for minute. Clear? So but all of the time to be written in seconds only. Clear? So first diagram, it's clearly saying that it's going to be how many seconds? This is the second, okay, the outer side circle. So it's going to be 22. So here the time is actually 22 seconds. So you note suggested to write unit like here S, because unit is already mentioned, so no need to write the unit of time here. Just write the number. Just simply write the yeah, the time. Okay, so the first one is 22 seconds. Second timer diagram, we look at it, it's going to be how much it is? 43, right? It's 43 seconds. And third diagram timer, look at properly, what is that? 1 minute. It's going to be 1 minute and past 1 minute, 1, 2, 3, 4. Okay, 1 minute 4 seconds. So 1 minute 4 seconds means you should not write like this, 1 minute and 4 seconds. So this is going to be wrong. Okay, so you have to write all of them in seconds only. So that, how do you write it? 1 minute means 60 seconds. 60 plus 4. Okay, so you're going to write it 64 seconds. Similarly here, next diagram, so the timer diagram, it is about 1 minute. How many seconds? 15. It's going to be 26 seconds. Okay, 1 minute here, 26 seconds. So 1 minute equal to 60 seconds. So 60 plus 26. 60 plus 26 is going to be 86, I think, right? Yes, 86. Next one is 1 minute 45 seconds. So it is small, 1 minute, and this is 45 seconds. So 1 minute equal to 60 seconds. So 60 plus 45. So it's going to be how much? 105. Okay, so no need to write this addition value, just write 105. Just write 105 is enough. So 105 seconds. Next one is here, it's cross already. Look at it, 1 to 2 minute, right? 2 minute and 6 seconds. 2 minute and 6 seconds. So 2 minutes equal to how many seconds? 62 times is 120, 20 plus 6. So 126 seconds. Okay, so these are the timer you have written. So for this you got it 3 marks. Now look at, by using the total volume of sodium thiosulfate and the time at which the color, blue color appeared. So this we have to use for this graph. Okay, B, plot the result you have obtained on the grid and draw the best fit straight line graph. So basically here the total time we got, it's about 126 seconds, right? And here the amount of total volume of sodium thiosulfate, the total volume is about 3.0 centimeter cube, right? So this graph should be drawn as per this, the volume of sodium thiosulfate used, and of course the time taken where the blue color appeared. Okay, so we have time in seconds. It's about 126 something, we got it total time, and the volume of sodium thiosulfate we can take until 3 centimeter cube. Okay, so draw the graph. So basically here already there in the x-axis the volume of sodium thiosulfate, and y-axis there is time in seconds. So you take in a proper manner so that all the time will be fit in this graph. Okay, the square lines you take maybe 20, 40, 60, 80, 100, 120, 130, it's like somewhere you just take it until here, so that will get a proper graph. So maybe this graph I'm going to, so Okay, now can it be seen to you? So here you could see the graph I have drawn it. Use the value of the sodium thiosulfate and the time period in the seconds. So here I have taken here in each big square box with the 20 seconds, 20, 40, 60, 80, 100, 120, 140, 160, and then 18 until 180 I have taken. So now in 0.0, yes, 0.5 centimeter cube of sodium thiosulfate, what is the time? Here we got it 22. And then secondly, third, fourth, fifth, until the sodium thiosulfate in 3 centimeter cubed. So we got it, it's about 126. So draw a proper line here, and you just extrapolation also can be done until where it's getting end. So ending point is of course here. Okay, so after getting straight line, you intersect the volume of sodium thiosulfate, of course time as well, so you will get a proper line like this, the main grid. Okay, main graph line. This is going to be the main line after intersection, and where you get it the endpoints, that's you just find the time. Okay, by drawing the line over here, like the horizontal line towards the time taken, so that you can find it what is in what times it's what is the time in seconds you're gonna get it. Here the color of the blue will be up here. Okay, so what they asked about it. So once again, let me move on to the questions. So in the question they asked about, see, first bit from your graph, deduce the time at which the blue color would appear if the total of 4 centimeter cube solution thiosulfate solution were added to the mixture of the conical flash. Show clearly on the grid how you work out your answers over here. And secondly, they are talking about sketch on the grid the graph you would expect if temperature was repeated at higher temperature. Sorry, the experiment was repeated at higher temperature, then what could be the graph you could expect? Okay, these two answer is very simple. You can just do it. So let me move on to the same graph again. Here, by 4 centimeter cubed, what could be the time taken? Okay, so that the blue color can be disappeared. So until 3 we have plotted. So here they are talking about 4 centimeter cube of sodium thiosulfate. If you add, then what could be the time taken? So that is why you have to have from here, we have to do extrapolation until the last, so that you can find the time. So time's going to be the range over here, it's going to be 168 to 70. So you can write range about 168 to 170 seconds. Okay, so this is going to be the answer for C first bit. And the second bit was asked about if at all the experiment was taken, the experiment was carried out in higher temperature, then what could be the graph you expected? So the graph you have to draw from your own, and of course we know that when the temperature increase, it's going to be one of the factors depend on the rate of reactions, right? If the temperature increase, then the rate of reaction of course will increase. That means it will have the in a less time, by less time consumption you can do, the reaction can be occurred. So that the graph you would be drawn here just simply just normal graph by your own here, just below the main graph. This is going to be the second graph. So you could expect this graph if the experiment were repeated at higher degree Celsius temperature. Understand? So why it will be just below the main graph? Why? Because temperature can increase the rate of reaction. So if rate of reaction increases, obviously it will take less time. So that graph will be just the below the main graph. Okay, because this main graph is actually the time is time in seconds are increasing, so that the rate of reaction will increase, so the time consumption will be less. So in a less time period, the reaction can be carried out. Okay, so that the graph you supposed to be expected if higher temperature the experiment to be taken, then this going to be the right graph. Okay, fine. So let me move on to the next questions. Is it clear, all of you? So your answer, you're supposed to write the answer here. It's about, what is the answer? 168, we got it, right? 168. You can raise the range also, no problem. Okay, fine. Next is this. Suggest the purpose of the start solutions. So what is the purpose of start solutions? Basically, it will act like indicators, right? This will be act as an indicator. This is the purpose that it's gonna work as an indicator. Simply write indicator. Next one, first one, suggest one advantages of using pipette to measure the volume of hydrogen peroxide. So what is the advantages of measuring the volume of hydrogen? Yes, volume of hydrogen peroxide by means of pipette. So pipette can measure accurate. So that's going to be the advantage. So it will be more accurate. More accurate. Okay. Next one is suggest and explain one disadvantages using pipette to measure the volume of hydrogen peroxide. Now you have tried disadvantages. Okay, what could be the disadvantage? Can we take kind of a measuring flask instead of pipette? Of course we can take, but here what is the disadvantage for pipette? Can you write? So two disadvantages you can write. Okay, first one is it is too slow. It will be complex and slow process. Slow to run out of pipette. Okay. Next one. Next point what you can mention. And it takes longer time. Longer time. It takes longer time. So these are the two disadvantages that we are using pipette to measure the volume of hydrogen peroxide. Okay. F, explain one disadvantage using beaker instead of conical flask. So what is the disadvantages using beaker instead of conical flask? So in the conical flask is of course, what is how the diagram, can you see? Diagram looks like this is the beaker diagram. Just let me do it. Okay, just a while. Okay, this looks like beaker, right? This is conical flask. Beaker supposed to be like this. It is actually beaker. So what is the disadvantages of using beaker than conical flask? So the answer you can write that, difficult to shake the solution here in case of beaker. Difficult to shake. difficult to shake the solutions. So that this is going to the disadvantages of beaker. This is so conical flask diagram seems to be ugly. Okay, it's not proper diagram actually. Conical flask supposed to be like this. Okay, I'm doing with the mouse, so it's not proper diagram. Okay, it looks like this. Okay, fine. So let's come to question number 3. This is very important question. Students, they tend to, get confused. So it's very simple if you understand the questions. Okay, so let's do. Two solid E and F were analyzed. Solid E was sodium sulfite. Both solids are found to be water soluble. The test on the solid and some of the observations are shown below. Test on solid E. First one, describe the appearance of solid. So student, it is clearly given the idea that solid E, they mention it is sodium sulfite. Sodium sulfite means it's supposed to be Na2SO3. Okay, so here we have two different ions, Na plus 1 ion and sulfite ion. Right, sulfite ion. Two ions are present. Cation is Na and sulfite. So always remember here what could be the appearance of this compound Na2SO3. So it's going to be the white, right? The appearance of this solid going to be white. So always remember the key point is the first group, second group, and third group compounds. Okay, the first group element like sodium, lithium, second group magnesium, and other third group elements are, if they are in the compound, they are always white in solid state. The appearance of the solid going to be the white. Okay, if they are in aqueous, then this compounds going to be the colorless. Okay, which the first group element which found in the form of compound, the second group also. So here we have a example. Here sodium sulfite. Sodium sulfite means the sodium going to the first group element. So here you can write the appearance. It is in the solid, so in the solid state the appearance always will be white. Always remember, for the first group compound, second group compound, and third group compound, they are in solid state. If they are in solid state, then the appearance will be white. If they are in aqueous solution, then they will be colorless. Colorless in AQ, in aqueous. Which group elements? First group and second and third group element if they are in the form of compound. Okay, so just write white. So next one is B. Distilled water was added to solid E in the test tube and shaken to dissolve. The solution was divided into two test tube and following test carried out. Okay, first bit, aqueous sodium hydroxide. It is NaOH. Was added to the first portion of solution. What could be the observations? What do you observe? Will the reaction occur? Will you find any changes of color? These are going to be the observations. So what you can see from your eyes. Okay. So basically here in this compound, you got it Na plus ion, right? Sodium sulfite is there. That means here there is a cation Na plus. Sodium is there. And you have added sodium hydroxide. Again, here we have Na plus. So will this reaction takes place? Do you will find or do you observe any changes? So there will be no changes because there will be same cation Na plus and Na plus. So Na plus is present in the solid, whereas you are adding sodium hydroxide as well. So that is why there will be similar ions. So no change, no change taken place. Just write no change. Clear? Now the next one. What is the next one? Dilute hydrochloric acid was added to the second portion of solution. The mixture was warmed. The gas given off was tested with a piece of filtered paper soaked in aqueous acidified potassium manganate solution. So look at it here clearly. This talking about the solid E was sodium sulfite. That means there will be sodium ions and sulfite ions are with SO3 2 minus ions. So always remember when sulfide ion is being heated, okay, there a gas is given up there talking. Okay, when sodium sulfite is the E compound, I mean solid E, so there will be sulfite is present. When this ion will be heated, so you always get it sulfur dioxide gas. Understand? So sulfur dioxide gas is a reducing agent. Reducing agent. So that sulfur dioxide will be produced here. So what you find, the sulfur dioxide will make the potassium permanganate color change from purple to colorless. Okay, purple to colorless. Okay, why? Because potassium manganate is a oxidizing agent. So this you can see acidified potassium manganate is a oxidizing agent. Okay, so that the color observation you will find it, the purple color change into colorless. Is it clear what happens, in sulfite? If you heat it, then it forms sulfur dioxide gas. So that sulfur dioxide gas is a reducing agent, so it can reduce the oxidizing agents like potassium permanganate solution will change the color from purple to colorless. Okay, so that is why we use potassium permanganate for the test of sulfur dioxide. Okay, so if there is sulfur dioxide, then the color changes can be taken place from purple to colorless. Okay, now come to see, a flame test was carried out on the solid E. Solid E means sodium sulfite. So when you go for the flame test, in the flame test, the sodium metal is present here and A plus is there. So you will get yellow flame. Always remember, sodium will give you yellow flame in flame test. Okay, yellow flame while you're burning sodium metal will get this flame. Next one. Now let's do for the test of solid F. Whatever we are talking about, that was solid E. Now we're going to test on solid F. So there is some observations and test is find over here. The solid was heated. The gas given off was tested with damp and red litmus paper. So always remember a famous gas that being used by the red litmus paper. Okay, that gas is actually ammonia gas. Only ammonia gas will be tested by red litmus paper, so it can change into blue color. So look at some of the observations. So it's pungent gas evolved. Red litmus paper turns blue. That means they're talking about ammonia, NS3. So on NS3 is a pungent smell gas, and ammonia can be tested by taking red litmus paper. So it will turn blue color. This is the preliminary test, and let us confirmatory test is here. Aqueous sodium hydroxide was added to the solid F and mixer heated. The gas given off was tested. So this is for the confirmatory test. So in the confirmatory test also you get the gas given off. Okay, and the pungent gas evolved. The universal indicator paper of pH value 10. That means they're talking about this became base on. It is also a base, right? Is it clear? Now You got confirmation that here there you'll be finding here ammonium containing ion only. So it's going to be NH4 plus. Okay, so there will be ammonia. So ammonia can be tested by using damp red litmus paper. So it will become blue color. So what they asked, let's see how we can answer for them. Okay, so identify the gas given up in the test on solid F. Already I told you which gas. What is the name of the gas? Very simple, ammonia. So you can write NH3, NH3, or write in word ammonia, ammonia gas. Okay, so next one is identify one of the ion on solid F. What ion is present here? So obviously here they're talking about ammonium ion, isn't it? The ammonium ion will be present. So NH4 plus. So NH4, NH4 plus ion. So you just write ammonium ion. Okay, from ammonium ion only we'll get it ammonia, right? So the answer you can write it in this way. Okay, fine. Next. This is the last question is, yes, this is also very simple. Look at question number 4. Potassium sulfate is a salt produced when sulfuric acid is neutralized by potassium hydroxide solution. The correct amount of potassium hydroxide solution must be added to the neutralized all of the sulfuric acid. Plan an experiment to obtain pure crystals of potassium sulfate from sulfuric acid and potassium hydroxide solutions. You are provided with common laboratory apparatus. So plan and investigation questions. It's very simple. It seems to be, this question seems to be titrations. Why? Why? Because here you could see the sulfuric acid is neutralized by potassium hydroxides. This potassium hydroxide is a alkali, whereas sulfuric acid is an acid. Okay, when there is a reaction between alkali and acids, we'll be getting salt and water. So this reaction is known as, what is that? Neutralization reaction or titration also, right? Okay, so first write the titration. How are we gonna do it? For the titration, we need to have, beaker, sorry, a conical flask, burette, pipette, and of course indicators is required. And then to get the pure crystals, of course, we have to do crystallization. Just two step you can answer it. So maybe here let me write the answers. So let's do the titration. It's very simple. Acid is known and potassium hydroxide also is here. Okay, so you will be getting the salt solution. After getting the salt solution, that has to be crystallized. Okay, fine. So what is the first step? Let's do the titration for these questions. It is how many marks? I think it is 6-mark questions, right? So in the titration, how we do? Basically, we prepare 20 centimeter cube of sulfuric acid, right? We prepare, first point, you can write it. Prepare how much? 25 cm cube of sulfuric acid. H2SO4. Okay. Where you have to take it? You have to take in conical flask. Second step, what you do? Okay, so and then in the conical flask, after that you just prepare the acid also here already. Sorry, acid is already prepared the base. I mean potassium hydroxide. Prepare how much? 50 centimeter cubed of potassium hydroxide, KOH. Where you have to take it? In burette, right? Third step, of course, we need to add indicators. So add, maybe you can use phenolphthalein or methyl orange, it's fine. Add indicators, so add phenolphthalein. So phenolphthalein indicators. Okay, you write correctly the spelling. You locate it proper and write it phenolphthalein. Phenolphthalein spelling, what is that? PHENO, PH, TH, right? Phthalate. Okay. So add phenolphthalein indicator. Where we should add? In the conical class. Into conical class. Because here in the conical class we have already taken the acid. Done. So after, what you have to do? You have to do titrations. Do titration. Okay. Do titration until the color changes from colorless to pink color, right? Colorless to pink. Basically, you know, phenolphthalein will be colorless in acids and it will be pink in base. So in the conical class, we have taken sulfuric acid. So that is initial color of this solution going to be colorless. And when you titrate, when you add the base into the acids, so you will get the endpoint. So before that, make sure that you have added this indicator so that when it neutralizes, you will get the changes of colors. I mean the colorless to pink. Okay, so the next step, what you do, you have to repeat the volume. You record the volume, right? How much you have added. So where the endpoint you get it. So you need to record the volume. After recording, you have to repeat it for 3 times at least. Okay, so just repeat it. Repeat and take average. Okay, so after getting endpoints, so you just record the volume at how much potassium hydroxide you have added, okay, into the acid and where it's neutralized. And the second step, this after getting the salt solution, the solution to be taken into crystallization. So let's do the crystallization process. Crystallization, right? So crystallization is very simple. First step, you can do it like, you know, evaporate the neutral solution. What you get it in the neutralized solution by titration, you have to just evaporate it. Okay, evaporate the neutralized solution. until saturated, right? Until saturation point. Second step, what you do? Leave to cool. For cooling, you have to leave to cool. And after cooling, of course, you have to wash the crystal on filter paper. Wash the crystals. Okay. Okay, and then dry it. You have to dry it, right? Wash properly and then dry them. Dry the crystal. After drying, where you will dry it? On filter paper. Okay, the next one is the same as it is, like how you take it to, average and compare it. So after drying it, you will gonna get the salt. Okay, so just right here, last point is repeat and compare it. Comparison must be done, right, to get the appropriate values. Okay, repeat and go. Yeah, thank you. Once you go through it, what is the process you're supposed to do it? So first titration you have to do, and then followed by crystallizations, because you have asked to write here how to get pure crystals. How to get pure crystals. So of course you will do the titration first and then followed by crystallization. It's a very simple process. You already remember this, right? Okay, so that's all from this paper. So thank you so much for watching this video.